Hello viewers, welcome to Civil Learning Online, and today in this video I will be solving a numerical based upon the three-hinge arch. As we all know that three-hinge arch is a determinate structure. It means we can analyze the three-hinge arch using the equation of static equilibrium, and I will be adding some videos related to three-hinge arch which are sufficient to clarify all the doubts or are sufficient to solve any types of numerical related to three-hinge arch. Without any further delay, let's get started and stay connected with Civil Learning Online. So our question is, a three-hinge arch has a span of 30 meter and a rise of 10 meter. The arch carries a UDL of 0.6 kN per meter on the left half of the span. It also carries two concentrated load of 1.6 kN and 1 kN at 5 meter and 10 meter from the right end. Determine the reactions at the support. This is going to be my first video on the related to three-hinge arch. Further I will be adding some videos more, and first let us draw the arch and solve this numerical. So here is a three-hinge arch. Three-hinge arch basically has three hinges. Suppose two hinges are at support and these two are at support, namely this is A, this is B, and the third hinge is at the crown here, and let us name it as C. Now what the question says, the arch carries UDL of 0.6 kN per meter on the left half of the span. This is our left half. This is half, total span is this much, then half span means left of the half span is loaded with UDL of 0.6 kN per meter. So let us draw it. So this is going to be our UDL on the left half of the span, which is 0.6 kN per meter. Now it also carries two concentrated load of 1.6 kN and 1 kN at 5 meter and 10 meter from the right end. This is end B is our right end. So from end B at 5 meter distance, here is one point load, and again from end B another point load is at distance 10 meter. So here this is 5 meter and this is 5 meter. So the point load, second point load is at distance 10 meter from B, and the first point load is at distance 5 meter from B as per the question. So let's put the point load now. This 1.6 kN is at 5 meter and 1 kN is at 10 meter. 1.6 kN is at 5 meter from B. Similarly 1 kN is at 10 meter from B. And let the horizontal reaction at A be HA and horizontal reaction at B be HB. Similarly, let the vertical reaction at A be VA and the vertical reaction at B be VB. Now let's begin the solution. So here in step 1 we will be finding the support reaction. Step 1, calculation of support reaction. So for calculating the support reaction, we will be applying the condition of static equilibrium. So let us apply summation moment at A equals to 0. Now for this part, moment at A, we need to take moment about this point A. Let us draw a beam similar to the loading as in arch, and which will help us in understanding and making the solution more numerical, more efficient. I am doing so because it will help you in understanding or finding the moment easily. You may be new in this topic, but when you have practiced, then you do not need to draw the beam. It is just for understanding, to make the understanding more easier. and the total span of this beam is going to be 30 meter. And just I have simply copied this loads on a beam which is simply supported beam. Now let us take a moment about A. If you take moment about A, then we will have VB into 30 meter, which is taking our anti-clockwise direction. So we will write it positive. So VB times 30, and these loads are acting downward, so minus, taking UDL 0.6 into, and the span of this UDL is half of this span, so this is going to be our 15 meter up to here. So 0.6 times 15, and this is our point load. If we multiply UDL by span, then it get converted into point load. Now we need to multiply it with CG because the UDL acts at CG, so half of 15 meter. Now it gets converted into moment, and minus 1 into 15 plus 5 meter, so 20 meter, minus, this is taking clockwise direction, so clockwise all the loads are acting clockwise direction, so this will be, all the load will be negative, minus 6 into 25 equals to 0. And on solving this, we will get the value of VB equals to 4.25 kilonewton. Now we need to apply the another condition of static equilibrium, that is summation Fy equals to 0, means sum of the forces in vertical direction. So we have VA and VB are acting in vertical direction, and these loadings are acting in downward direction. So VA plus VB equals to sum of all the forces acting downward, and the sum of all the forces acting downward is 0.6 into 15 plus 1 plus 1.6. Now here put the value of VB and calculate the value of VA, which will be equals to 7.35 kilonewton. Now after applying, we have one more condition of static equilibrium, that is summation Fx equals to 0, means sum of the forces in x direction or horizontal direction is 0. Sum of the forces in horizontal direction, here the forces acting in horizontal direction are mainly HA and HB. So HA is acting towards the right hand side, so it will be positive HA, and HB is acting towards the left hand side, so it will be written as negative HB negative equals to 0. And from here we will have HA equals to HB. Now let's move toward step 2. And as the question says that determine the reactions at the support, means we have to find the reaction of the vertical forces and the reaction of the horizontal forces. Here the reaction will act along this side. We have to find this value. It means we will need the value of both things, that is HA and VA. We have got the value of vertical forces, but we have still need to calculate the value of HA and HB, and we from this condition of static equilibrium we have come to know that HA is equal to HB. So in step 2 we will be finding the horizontal forces. So let's write it down. Calculation of horizontal forces. So for calculation of horizontal forces, we will be taking the moment about the crown, that is moment about C, and it has a special case in 3 Hinged arch that the moment about the crown, that is moment at C, will be 0. So let's write it down. We will write here moment at C means MC equals to 0. Now let us take moment about C. This is our point C. So taking moment about C, we will take, if we are taking on LHS side, then this is taking our clockwise direction and this is anti-clockwise direction. Let me show you the sign convention for the moment. See here guys, this is positive, positive, negative, negative. So from here in the above step, that is taking moment about A, we have used the sign convention of this side. It is up to you. You can use the sign convention of any side, either this or this. And for the calculation of moment about C, I will be taking the sign convention of this side. So our VA is acting upward, so taking clockwise direction, so it will be VA times 15, and the UDL is acting downward, so 0.6 into 15 into 15 by 2. There are no more forces on the span AC, so equals to 0. Now from here, this was for the loading. Now we need to bring the horizontal forces also here, and for that we need to move in the arch. Now see here guys, if we support, if we take moment, we are taking moment about C, and the horizontal forces is will take our anti-clockwise direction. So for anti-clockwise direction we have negative forces, so put the sign convention as negative here, as I have done here, and negative into HA. Now see here guys, we have moment equals to force into perpendicular distance, and this is our force which will move like this manner in anti-clockwise direction, and the span of and the perpendicular direction will be this. So span is our height of the crown, that is 10 meter. So HA will be and the final here will be HA times 10, which will be equals to 0. Now put down the value of VA, that is 7.35 into 15 minus 0.6 into 15 into 7.5 minus HA into 10 equals to 0. Now from here we will get the value of HA, which will be equals to 4.275 kilonewton, and from the equation of from the static equilibrium we have come to know that HA equals to HB, so we will have HB equals to 4.275 kilonewton. Now we need to find the reaction at the supports. So we will be doing that in step 3, but here let us see a diagram. Here we have, here this is HA, this is VA, and this is our reaction. So we will need to find the value of R as well as this angle at which the reaction is acting. So let us move toward the step 3, which will be the final step of this numerical. So let us write it down, step 3, and here we will be calculating the reaction at supports. So for reaction at A, let us draw a diagram, simple diagram. Here, this is our HA and this is our VA, and the reaction is R, and let this be angle phi. So what we are going to do is, we have from the triangle law of vector addition, R equals to root under VA square plus HA square, and we have got the value of VA and HA. So put down the value 4.275 square plus, this is the value of HA here, and the value of VA is 7.35 square, and from here we will get the value of R equals to 8.5 kilonewton. Now we need to find the value of this angle phi. So we have a formula, tan phi equals to VA upon HA. So from here we will have tan inverse equals to VA by HA, which will be equals to tan inverse, and the value of VA is 4.2, value of VA is 7.35 upon, and the value of HA is 4.275. Now let us find the value by using the calculator. See here guys, Oh, it's not visible to you guys, but here, see here, shift tan inverse. This is the tan inverse. Shift and press this tan, you will get tan inverse. Now put down the value here, shift tan inverse and put down the value 7.35 divided by 4.275. Here the theta value comes to be 59.82 degree. Similarly, we need to do for the reaction at B. Let's write it down. Reaction at B. Again we will be drawing the same diagram here, and let us draw. This is our B, this is HB, VB, and reaction at B, that is RB. So again we will be using the same formula, RB equals to root under HB square plus VB square. Now put down the value of HB and VB, and I have denoted this angle as alpha. So we have alpha equals to tan inverse VB by HB, and now putting the value, we will get the value of alpha equals to 44.83 degree. So as per the question, as we were asked in the question, to calculate the reactions at the supports, and we have calculated the reaction at A and reaction at B. This was our final step, and I hope this video was very helpful to all of you guys. I will soon be back with a new video with the new concept based upon the 3 hinged arch. So stay connected with Civil Learning Online. Do like, share and subscribe to Civil Learning Online. See you. Have a nice day.